Hello, my name is Jared Skeens. Welcome to the Zoom room. Today, I would like to start the first part in a series on trigonometry. And the focus is specifically towards the Pure Math 1 Cambridge curriculum. And this first part in this trigonometric series will be an introduction. So there'll be some review and some foundational elements that are necessary as building blocks in our developing of trigonometry. So really, trigonometry is a different platform from algebra, but many of the things that are in the trigonometric platform are algebraically based. So that's why algebra is important to develop first. Then once you understand algebra, then you can transfer over into a trigonometric platform. So what I want to do is I want to focus mainly on the things necessary for the Cambridge Pure Math 1 curriculum with regards to trigonometry, the trigonometric type questions that they have. So the first thing I want to do is a little bit of review. Now this should have already been covered in the IGCSE part back in grade 8 or 9 section, maybe even grade 10. So just to review, here we have this Soh Cah Toa that a lot of people are familiar with. And you have a basic right angle triangle. And so from this, we get Soh Cah Toa. Now, remember, algebra focuses on the sides of a triangle. So you get like the Pythagorean theorem, a squared plus b squared equals c squared. So you'd have your a squared plus b squared equals your c squared. So algebra focuses on the side. Trigonometry has a relationship between an angle and the sides. So it gives a little bit different perspective of the triangle than purely algebraic. So what's important to remember in trigonometry is your point of reference. Just like in an algebraic Cartesian coordinate plane, we use the origin, the 0, 0 at the center, as our point of reference. Similarly, in trigonometry, it's very, very important to establish your point of reference. We all need to start from the same point of reference. Right now, my arm is facing that way, okay? So someone facing me, their right arm is facing the other way, okay? So it's important that we have that same orientation and direction to start with. So in trigonometry, the most important thing is identifying your point of reference, your orientation, and that's going to be the angle from which all your directions come from. So I put a little arrow here indicating that this angle is my point of reference. I'm standing here at the corner looking out that way, as opposed to, say, this angle over here or this angle down here. So establishing your point of reference is crucial in any kind of math, but specifically in trigonometry where you're dealing with angle measurements and there are different angles that are present on the board here. So this is our point of reference. And remember, we remember from Soh Cah Toa that the opposite side is the direction that you're facing. So here we're facing this way, and if you continue across, you get to the opposite. This is the opposite side from this angle. We also know the hypotenuse is always across from the 90 degree. Here we see this little box indicating this is a right angle or a 90-degree angle. The hypotenuse is always across from the 90, and it is always the longest side of a right triangle. So those are the two easy ones to identify. Then we have the adjacent side. Well, adjacent means next to. So if I'm standing here, I actually have two sides that are next to this corner here. I've got this side next to me, and I have this side next to me. So the adjacent side is going to be the non-hypotenuse side. So from our angle, we have the opposite side. We have the adjacent, the one next to you, and we also have the longest side, which is the hypotenuse. So opposite, adjacent, and hypotenuse are the three sides that you need to be able to establish after you've first chosen your point of orientation. For example, if you came from this angle over here, this one would then be the opposite, and this one would be the adjacent if you were coming from this perspective. So it's really important to establish your orientation first. From your point of orientation, you can then establish which is opposite, adjacent, and hypotenuse from your point of reference. So now, like I say, this is review. So I'm not developing this like I would if you were just learning it. This is something you should have already learned previous to the Pure One math book. So I'm just reviewing it. So you should already be familiar with Soh Cah Toa. The S is your sine trigonometric function. So sine equals sine of an angle, sine of theta equals the opposite over the hypotenuse. Cosine of the angle equals the adjacent over the hypotenuse, and tangent of the angle equals the opposite over the adjacent. So these are things you should have already learned prior to the Pure One math book. That's why I'm not taking a lot of time to develop it, just review it. So Soh Cah Toa is a fundamental prerequisite building block to our trigonometric system that we want to develop further as we move into the Pure One math book. And even later, if you go into the Pure P3 math book, you'll even develop it even more yet. So Soh Cah Toa, the basics, sine, cosine, tangent, those three trig functions are always taken of an angle, and then you have your relationship of opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. This is the beginning of your trigonometric journey that we review. Now, another thing that you should have also learned are special triangles. Sometimes a textbook will ask you for exact values, and anytime it's asking for exact values, it does not want decimals. Decimals are not exact. They are the least exact mathematical representation. So especially the ones that don't terminate. So special triangles are angles that are of special importance in our trigonometric system. They are ones that you should be able to work with without a calculator. Okay, so anytime it wants exact values, it means you should be able to work through it without using your calculator. So what you can use are these special triangles. We have the 30, 60, 90 right triangle, and we have the 45, 45, 90 right triangle. So here you see the 30 is the little one up in the corner here, and then down here a little bit bigger one's the 60 and the 90. And the relationship of these will follow a 1, 2, √3 pattern. The 30 is the smallest angle, has the smallest value. The 60 is the next biggest, and √3, I think √3 is something like 1.7. And then the 90 is the biggest angle, you have the 2. So the 1, I usually do 1, 2, and √3 because 1, 2, 3. So the 1, 2, and root 3. On our 45, 45, 90 right triangle, the 45s are the same, therefore the sides are the same. The angle across from 45, or the side across from 45, the side across from 45. Same length, same angle. So the 1, 1, root 2. Notice the 2 is the hypotenuse of both of it. This one's 2, this one's root 2, but the 2 is on the hypotenuse of both. So it can help you remember if you're trying to remember the special triangles. This one follows 1, 2, root 3, where the 2 is on the hypotenuse. This one is the 1, 1, root 2. Again, the 2 is on the hypotenuse. But from this, you can develop all the angles in the various quadrants. So I'm just going to refer over here to the unit circle really quick. And our unit circle is broken up into 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. Starts from the right here. This is where our 0 degrees, our point of reference is facing to the right, the positive x-axis, the 0 degrees, and it goes counterclockwise. So this is the first quadrant, goes against the clock, counterclockwise. First quadrant, second quadrant, third quadrant, fourth quadrant. We'll come back to this, but these angles, for example, 30 degrees would be in the first quadrant. But this 30 degrees could also be over here in the second quadrant. So 30 degrees from 180 would be 150. So 30 and 150 use the same triangle. If you do 30 down here, that's a 210. If you do 30 over here, remember a complete circle's 360. So if you do 30 down from that, you're at 330. So 30, 150, 210, and 330 all use the same special triangle. You can do that with 30, 45, and 60 in all the quadrants. And if you put it all together, you would get something like this. Now, I'll take a different sharing session to go over all of this, because this includes degrees and radians and your exact values from your special triangles. But I don't want to take all that time right now. So I'll do a separate session just to go over this, because a lot of students struggle with the different units. What I'm going to talk about today is just degrees, to keep it simple. It's a little easier to think in degrees. So then when I do a session on this, I'll cover degrees and radians and the exact or these special triangles and try to tie it all together. But I'll have a separate session for that. So these are both review. You should already be familiar with those. They should have already have been taught to you at some point, but they are fundamental and worth the review, because trigonometry is a very large platform of mathematics, just like algebra is very large. So you can't just cover it in a couple of sessions. So these are the fundamental units. Now, normally when we think of trigonometry, as the name suggests, tri is 3, gon is side, metry is measurement. So a 3-sided measurement, we think of triangle. A lot of people think of trigonometry with triangles. And it is true that we break it down essentially to a triangle. But the trigonometric system is actually based on a unit circle, not on a triangle. Although the triangle, you will see that we still make triangles within the circle. But it is the unit circle that is it's actually the geometric figure from which the trigonometric system develops. So, if you get later into, say, hyperbolic functions, comes off of a unit hyperbola. Trigonometric functions come off of a unit circle. So it might be a little confusing because we always draw triangles, and even the word 3-sided measurement, but the trigonometric system itself, the platform, uh, is kind of really a combination of triangles and this how the triangles fit within this unit circle. So the unit circle is fundamentally important for our understanding of trigonometry, not just the triangle itself. So you learn the triangle first, back at the beginning when you're just being introduced to it. And depending on your teacher as to whether or not they put that into how soon they put that into the unit circle. But so for those of you who maybe not have been introduced to the unit circle, now is the time that you need to understand that, because as we get into this P1 material, we will refer back to the unit circle frequently, and you need to understand how it works. So let's start with a very basic comparison of algebraic versus trigonometric, just on a fundamental level, say the location of one point on a graph. So in algebra, you use the Cartesian coordinate system, which is your X and Y axis. If you have graph paper, your graph paper is a bunch of lines and little boxes. So you start from your origin and you count in the x-axis direction, either positive, so here's +1, or negative, here's -1. You also count in the y-axis direction, here's the positive direction, +1, here's the negative direction, -1. So you start from the origin and you count using x-axis and y-axis. So if we wanted the location of this point right here, we would count over on the x-axis and put that number here. And then we would count up to the point on the y-axis and we would put that number there. So the coordinates, or the location of this point with respect to the origin, would be the coordinates x, y. You're familiar with that. Trigonometry is similar, but it follows a different way of arriving at the location. So instead of going x-axis and y-axis, it starts with standing at the origin and you're facing a particular direction. And the direction that we're facing is this positive x-axis direction, and we're facing what we call the 0 degree. In other words, we have not rotated anywhere yet. We're facing the 0. And then from 0 degrees, we begin to rotate. Now, if you rotate in the counterclockwise direction, that is the positive direction. If you rotate the other way, the clockwise direction, that is the negative direction. So just like your x-axis has a positive direction and a negative direction, your rotation also has a positive or a negative direction. So I just put that on here so that you can see going this way, you have 0, 90, 180, 270, 360. If you're going in the positive direction, if you're going in the negative direction, this would be -90, -180, -270, and the -360. We're not going to deal with the negatives now, but you need to realize that the negative direction, you will have to incorporate that into your understanding eventually. So for right now, I'm going to focus on the positive direction. So if we're standing here at the origin and we're facing 0 degrees and we rotate in the positive direction until we're facing the point. So the theta is the measurement of how far we rotated. Well, there are different ways of measuring angle rotation, just like there's different ways of measuring length. You can measure length in meters, you can measure length in feet, so like the English system versus the metric system. Same thing with temperature, you have Celsius and Fahrenheit. Well, same thing in trigonometry. We have degrees, which basically is based on a system of 360 degrees in a circle. And you also have what's called radians. Now, I'm not going to get into radians right now. radians is basically a non-unit unit, and I don't want to take time to get into that. When you get into more of your, say, science application, they will use radians because you don't have to pay attention to the unit. In other words, there's not a unit you really write down and keep track of that as a variable. Whereas if you use degrees, the little degree sign, that's a unit, and you have to keep track of it. However, we tend to think a little bit, it's a little easier for our minds to work with degrees for whatever reason, maybe because we're introduced to it earlier. So I'm going to stick with degrees for now. And then later, when I do the other session, I'll introduce radians and maybe explain radians for it. But maybe at some point you've already had radians explained to you in circle measurements prior to this. But for right now, I'm going to stick with degrees because it's easier to work with. So again, we want to get this point. We've rotated a certain measurement. And so this measurement will be so many degrees. Then, once we're facing that direction, we then have to move forward along this line. How far are we going? Are we going this far, this far, this far? It keeps going out. So that length, that magnitude, is called the radius of the circle. In fact, if you look at trigonometric graphing, algebraic graphing uses a Cartesian coordinate system with a bunch of lines and little boxes. Well, if you do trigonometric graphing, it often uses what's called polar graph paper and has a bunch of little concentric circles, so that once you've rotated to a particular direction, you can go 1 circle, 2 circles, 3 circles, however many circles out from that. So you have a bunch of concentric circles, and then you decide how far you want to go in that particular direction. Now, we don't, and the Cambridge doesn't use polar graph paper, so you don't have to worry about that. We'll just use the algebraic representation, but using trigonometry. So for example, a trigonometric representation would use something like this, r theta, as the notation for the location of that point. We're going to stick with algebraic notation and just substitute in the trigonometry. So this is the way the Cambridge questions are asked. We don't really need to get into the notation of polar graphing. We can stick with algebraic notation and just substitute the trigonometry. So just letting you know that there are different notations out there, and I'm sticking with what is needed for Cambridge Mathematics Pure Maths 1. So here, notice if we do our Soh Cah Toa on this triangle, from this angle, the x is the adjacent side. So since x is the adjacent side, adjacent over hypotenuse, and because we're dealing with the unit circle, our hypotenuse is 1. So adjacent over 1 is the cosine. So the x-coordinate, or the x-axis, is the adjacent side of my triangle. Notice an important orientation in trigonometry is I'm drawing the triangle to the x-axis. I am not drawing the triangle to the y-axis. Technically, you can draw to the y-axis, but it throws off all your orientation. And I would not recommend that. There's no need to do it in the Cambridge system. I guess there is one example in the mechanics book that comes to mind where I have drawn triangles to the y-axis in dealing with factors or forces, resolving forces. But for Pure Maths 1, there's no need to draw the triangle to the y-axis. So please do not draw your triangle to the y-axis. Draw your triangle to the x-axis. That way your orientation is always the same for it. So because the x-axis will always be the adjacent, it means the x value is the same as cosine of the angle. So our algebraic is now converting into trigonometric. X is cosine. So instead of putting x, I can put cosine x. So we're using the notation of the algebra, but we're putting the trigonometry. Same thing with over here. Over here is the opposite. Well, the y-axis is opposite of the angle next to the origin. Here's the origin, here's the angle. The opposite is the vertical, that's the y-axis. So the opposite is our sine function. So a location of a point in algebra would be xy. The location of the same point in trigonometry would be cosine theta, sine theta, if you know the angle measurement. So this is the fundamental building blocks of the entire trigonometric platform of mathematics. Everything in the trigonometric system that you learn and develop from here on out is based fundamentally on sine being your y-axis, cosine being your x-axis, and you could get into a lot of different, trigonometry branches off into a lot of different areas. We don't have time to explore all of those different areas, but basically everything that you learn from here on out is going to be fundamentally based on sine and cosine. Those two are the Lego blocks for the entire trigonometric system, okay? So we're only going to focus on those things that the Pure Maths book for Cambridge focuses on. Even though there's many other exciting things that you could branch off into, I want to keep it to what we need, okay? So you need to understand cosine is x, sine is y. In a unit circle, your radius is 1, and this is the basics. Now, what I want to get into a little bit are some vocabulary that relates to the angle. This is going to be important on some of these certain question types. It's not the fundamental question types. Cambridge mainly focuses on identities. I'll have a separate sharing session for identities, focuses on solving trigonometric equations. I'll have a separate session on that. But there are a few questions that relate to your understanding of the angle within a unit circle. So I'd like to go over those vocabulary words right now. Now, the first vocabulary word is the word acute. And acute, you should already know, is less than 90. So any angle rotation that is between 0 and 90 is going to be acute. So that word acute is the key word for you to know that you're in the first quadrant. Now, if you were to take your angle measurement and rotate beyond the 90 into the second quadrant, over here, now your angle rotation is over here, and you come to this point over here, this is now called obtuse, because you're greater than 90 but less than 180. So from 0 to 90, the angle is referred to as acute. From 90 to 180, that angle would be obtuse. In other words, it's greater than 90. However, your triangle is still drawn to the nearest x-axis. So the adjacent side is still your x-axis. Now you have another vocabulary word in here. This is now called your reference angle. So we have acute, we have obtuse. I'm going to write reference up here. Your reference angle is just meaning the angle between your hypotenuse and the nearest x-axis. So in the first quadrant, your acute angle is the reference angle. In other words, it's already to the nearest x-axis. Whereas an obtuse angle, which is actually going from 0 over to here, this is the obtuse angle. So your reference angle is the one in the triangle to the nearest x-axis. So this is the obtuse angle. This is your reference angle. Your reference angle is what allows you to work with your special triangles. When you get into working with your calculator and stuff, your trig functions basically give you answers that are generally reference angles, with the exception of cosine. So you need to be able to work with reference angles. So acute, again, 0 to 90, it is your reference angle. Obtuse means you're in the second quadrant, and your reference angle is in here. Then you have a word called the reflex angle. Okay, so we have 4 vocabulary words that you need to be familiar with. Acute, first quadrant. Obtuse, second quadrant. Now, the reflex angle is the angle outside of, is like the outside angle. So if you say acute is from here to here, then the reflex angle is all the way to here. If your obtuse is over to here, then your reflex angle is from here the rest of the way around the circle. So your acute stops here, the reflex is the rest of the way. Your obtuse stops here, the reflex is the rest of the way. So you can see that your reflex, if we go backwards from the 0 this way, your reflex covers 1, 2, into the third quadrant to get to the obtuse, or even into the fourth quadrant to get all the way around to the acute. Okay, so the reflex is the outer angle. So when you're working with these question type, or this question type that uses this kind of vocabulary, you want to make yourself a little triangle, or you want to at least draw a line in, first of all, into which quadrant you're dealing with. So when it says acute, you're going to draw into the first quadrant. When it says obtuse, you're going to draw a line into the second quadrant. When it says reflex, you're going to have to think a little bit, because it could be third quadrant or it could be fourth quadrant. So then what you're going to have to do is you're going to have to look at the sign, that is the positive negative, of a trigonometric function, and it will either give to you cosine or tangent. Now, so let's look at a way that you can keep track of the positive negative of your trigonometric functions. So I call it all students, notice we're going in order of the quadrants, first quadrants, all students take calculus. All students take calculus. Now there's different ways of learning this, okay? This is the way that, that I use in my mind when I'm trying to figure out the positive negative of trig functions. So starting with first quadrant, going around in order of the quadrants, all students take calculus. Now what does this mean? This means the A, the all trigonometric functions are positive in the first quadrant. So notice on the x-axis, we're going in the positive direction, and in the y-axis, we're going in the positive direction. all are positive in the first quadrant. When we get over to the second quadrant, notice your x-axis is now going in the negative direction, but the y-axis is going in the positive direction. Sine is your y-axis. Sine is positive in the second quadrant. So sine, which is your y-axis, is going to be positive in the first and second quadrant where it's going up, the y-axis. And sine is going to be negative in the third and fourth quadrant where your y-axis is going down. So all students means sine is positive here. All are positive in the first, sine is positive here. Now, take. Take is tangent. Tangent is positive here. So notice cosine is negative, sine is negative, and two negatives make a positive. If you remember back to your tangent, your tan theta equals sine theta over cosine theta. So not sure whether you've learned that before or not, but tangent is sine over cosine. So a negative divided by a negative is positive. Tangent is positive in the third quadrant. Now, if you move over into the fourth quadrant, you have all students take calculus, cosine. Cosine is positive in the fourth quadrant because it's going in the positive x-axis direction. So what this gives you is it gives you those trig functions which are positive. All are positive, sine is positive, tangent is positive, cosine is positive. So if you know the positives, then by default, you can figure out the negatives. If all are positive here, means none are negative. If sine is positive here, well, it means cosine and tangent are both negative. Tangent is positive here, well, sine and cosine are both negative. Cosine is positive here, so sine and tangent are both negative. So each trig function is positive in two quadrants and negative in two quadrants. So for sine, it's the y-axis, first and second positive, third and fourth negative. For cosine, which is your x-axis, first and fourth quadrant positive, second and third quadrant negative. Tangent, which is like the division of the two, positive in the first and third, positive divided by positive is positive, negative divided by negative is also positive. So tangent is diagonal, these two positive, these two negative, okay? So back to our angles here, acute means you're in the first quadrant, all your trig functions are positive. Obtuse means you're in the second quadrant, meaning your sine is positive, but your cosine and tangent are negative. If it's a reflex angle, you're either in the third or fourth, and the word itself doesn't tell you which one. So you're going to have to look at the information they give you with respect to either cosine or tangent. The reason why they won't use sine is because sine is negative in both of those. It won't help you. So it has to refer to either cosine or tangent. Now, if your cosine happens to be positive, well, you know your reflex angle's in the fourth quadrant. If your cosine happens to be negative, well, you know that your reflex angle is in the third quadrant. Same thing with tangent. If tangent is positive, you know your reflex is in the third. If your tangent is negative, you know your reflex is in the fourth. So on the questions that use this kind of vocabulary about angles, acute, obtuse, or reflex, make yourself a little unit circle, draw a line into the appropriate quadrant. Acute, first, obtuse, second, reflex. Look at your trig functions, positive or negative, and figure out whether it's a third or fourth. Then draw your triangle to the nearest x-axis. So if it's down here in the third, your nearest x-axis would be up here. If it's down here in the fourth, then draw your triangle to the nearest x-axis up there. So it doesn't really matter where on the circle, you're going to draw it to the nearest x-axis to keep your orientation consistent. Never draw it to the y-axis. It will really confuse you. It's not that you can't, but then you have to think from a different orientation, and it will really confuse you. So until you get used to the trigonometric system, I would strongly recommend you only draw your triangles to the nearest x-axis. That way your orientation stays the same. So I'm not going to take the time right now to solve one of those kinds of problems. But I wanted to get you used to the vocabulary. There's a lot of vocabulary. There's a lot of orientation that you have to learn in trigonometry. So this is the introduction. We haven't really got to solving the Cambridge type questions yet. But I think this is foundational. You really need this for your understanding so that when you get to the questions, you have the background information that you need. And honestly, this is not all the background information. There could be so much more given to you. I will do a separate one on the radians, degrees, and special angles, the quadrantal angles, and how you can do those without your calculator. And maybe when I do that, I might do the angles type questions also, might throw that in there. We'll see. So this is the first part, and I hope this helps you develop your mental connection between the algebraic platform of mathematics and the trigonometric platform of mathematics. Just as your algebra continues to grow in your understanding, and you've already developed that probably at least into the quadratic realm, your trigonometric function is kind of just getting started and following behind because it uses the algebraic way of solving. So you kind of have to develop the algebra first. But now that you've got your algebra up far enough, your trigonometric can now follow behind, and you just need to learn how to convert your thinking from x, y into the cosine, sine, and tangent. Those are the three, really sine and cosine are your fundamental building blocks, but even tangent is included in the basic three, and you'll build from that because it goes on into a huge system. But if you can understand the basic building blocks, these are the Legos that will build all the different systems in trigonometry. So I hope this is helpful, and we'll see you again in the next session of our trigonometric series. Thank you very much, and thank you for joining me in the Zoom room.